So welcome to our last lesson of the unit and of the year, which is about hypothesis test with proportions. So we're going to talk about how we do categorical data. So sometimes instead of means, we are comparing a sample proportion. So the symbol we use for that is p hat to some hypothesized proportion, which is p0. We call this a one proportion z-test, and on our GeoGebra website we use the option that says z-test for a proportion. So basically the difference between when we do means and when we do proportions, if we have numerical data like what is your height? How many siblings do you have? Those answers are numbers, and the logical next step would be to find the mean or the average of those numbers. So we can find what's the average height for all of these people. What is the average number of siblings for this entire group? But with categorical data, right, where the answer to our question is a word like what is your eye color, it wouldn't make sense to find an average or mean because there's no average eye color. But we could find a proportion, right? What proportion of people have brown eyes? Something like that. So that is when we do proportions, is when we have categorical data. So as before, just like in 9.2, we start this process by writing a hypothesis statement. So remember that our null hypothesis is the initial thought or belief that we have. So a null hypothesis, which is H0 for this type of test, would be P standing for the proportion. P equals the hypothesized value. So this is not the statistic, this is not the sample data, this is what we think is true at the beginning of the problem. This might be called a population value or something like that. But this is what we originally think to be true. Our alternative hypothesis, HA, is that there's a change, that P is less than or greater than or just generally not equal to that same hypothesized value, right? So it's the same number between the null and alternate. It's just with the null, we're saying it's equal. With the alternate, we're saying it's less or greater or not equal. The null hypothesis, again, is our initial thought or belief about what's true about the population, and our alternative hypothesis is what we believe might be true. It's the change that we're testing for. So let's look at an example. A 1996 report from the U.S. Consumer Safety Commission claimed that 90% of all American homes have at least one smoke detector. A city's fire department runs a public safety campaign about smoke detectors, and they wanted to determine if the campaign has raised the local level above 90%. A building inspector visits 400 randomly selected homes in the area and finds that 376 have smoke detectors. So we know it's true for the sample. And sure, we could find a proportion, 376 divided by 400, and see is that proportion greater than 90%. But remember, our goal is not to see what's true about just a sample. We're trying to look and see or estimate what's true about a population. So the question is, does this one sample proportion give us evidence that for the entire city, the proportion of homes is above 90% with smoke detectors? Right? So we're never just looking for what's true about a sample. We're trying to decide what's true for a population. So let's do our hypothesis statements. So our null hypothesis, which is H0, is the statement that nothing has changed. So in this example, that would be that P equals 0.9, which is the proportion version of 90%. We never write things as percentages. We're going to leave them as decimals or proportions, so 0.9. Basically, this is saying that the local level is the same as the national level. 90% of homes have smoke detectors. Our alternate is what the city thinks might be true, what they're testing for, and they think that that level has raised, that it's gone above 90% since they had this public safety campaign. So they think that P is greater than 0.9, meaning they think the local level is more than the national level of 90%. So those are our hypothesis statements. So now let's move on and actually talk about how we determine this. So we're going to go to our GeoGebra website to find the p-value. So I'm going to go ahead and click over to there. Looks something like this. Now when you first go to the GeoGebra website, I'll put the link in the Edpuzzle, but there's always a link in the assignments and the quizzes and all of that stuff. But when you first go to that GeoGebra website, it's going to bring you to z-estimate of the mean, which is what we did in the last chapter when we were doing confidence intervals. So for today's type of test, which is a proportion hypothesis test, we're going to click on that drop-down menu and choose z-estimate of a proportion. Let me refresh this. There we go. So we're going to click to Z estimate of a proportion. And then it'll ask us these first couple of questions. So I see null hypothesis. So our null hypothesis was that P equals 0.9. So don't put 90 here for 90%, or otherwise you're going to get some really weird values that don't make sense. So 0.9. And then our alternative hypothesis was that P is greater than 0.9. We think the value has risen, so I'm going to choose greater than. And then for our sample, successes just means how many in our sample did the thing. So in this case, we're measuring how many have smoke detectors. So in the sample, it told us 376 of the homes had a smoke detector. And then that was out of N, which is our total sample size. So our total number of homes they looked at was 400. Once you've filled those things out, we now have down at the very bottom a p-value. So now we see our p-value is 0.0038. All right, so there's a little copy of what the website looked like when we filled it all out. And our p-value is 0.0038. So then from there, we do kind of the same thing we did in lesson 9.2 to come to some kind of conclusion. So our conclusion is going to be, do we reject the null or not? And then what does that tell us about our alternative hypothesis, which is what we were testing? So do we have evidence that more than 90% of homes have at least one smoke detector? So let's start with the reject or not reject part. So our little trick for that, my little rhyme, was if P is small, reject the null. If P is small, reject the null. So in this case, or small in general, means it's less than our level of significance. And if they don't tell you a specific level to use, we're going to use 0.05. So if 0.0038 is less than 0.05, we know we can reject the null. And in fact, that is true. 0.0038 is very small. It is much less than 0.05. So that tells us that we can reject our null hypothesis, because if P is small, reject the null. Kind of rhymes. You have to say it in a little bit of an accent, but that's a good way to remember. If P is small, reject the null. So what we're saying when we reject the null, if I'm rejecting that P equals 0.9, I'm rejecting the null, I'm crossing that out and saying no, that means I'm landing or I'm choosing this other hypothesis. So I'm rejecting the null and I'm saying I have decided that there is evidence that our alternative hypothesis is true. So I think P is greater than 0.9 because I've rejected the null. Right? So if I've rejected the null, that means I do have evidence of the alternate hypothesis that the smoke detector rate is more than 90%. So that is what our p-value would tell us. P is small, reject the null. And if we're rejecting the null, then we do have evidence of our alternate. Let's do one more example. So according to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25. An administrator at a large high school suspects the proportion of students at her school who have a part-time job is less than the national figure. So she takes a random sample of 200 of students from the school and finds that 39 of them have a part-time job. So again, we'll start with the null and alternate. Your null would be that everything's the same, that her school is the same as the entire United States, which would be that P equals 0.25. In other words, the job rate for her school is the same as the national rate, 25%. The alternate is what she thinks might be true or what she's trying to test, and she thinks that the proportion of students at her school who have a part-time job is less than the national figure. So she thinks that P is less than 0.25. In other words, she thinks that the job rate for her school is less than the national rate of 25%. So next would be to find our p-value. So again, I'm going to go to my little calculator. All right, this was in here from the last one, so I'm going to change it up. My null was P equals 0.25, and I'm testing less. My number of successes would be the number in the sample who have a part-time job, so 44 is my number of successes, and then N is the total number of people in the sample, which was 200 students. So I'm going to change that to 200, and now I have a p-value, 0.1636. So there's my little picture of what my calculator looks like. My p-value is 0.1636. Okay, so do we have evidence? Well, we have to decide first, am I going to reject or not reject? And the rule is if P is small, reject the null. Small means less than 0.05 unless they tell you to use a different level of significance. So 0.1636 is not less than 0.05. It's more than 0.05. So because it's not small, we cannot reject the null, right? Because if p is small, we reject the null. This p-value is not small, so we cannot reject the null. And if we're not rejecting the null, that means we're basically staying here at the null hypothesis. That means we do not have evidence of our alternate. So we're not rejecting the null. We're kind of choosing that as our conclusion. We do not have evidence of our alternate. So we do not have evidence that the job rate at this school is less than 25% because we did not reject the null. So this administrator does not have evidence that less than 25% of her students have a part-time job. So there's a couple of examples for you, and that is it for this lesson.